Hi students, in this video we're going to look at how to sketch polynomials. Now, so after watching this video you should be able to know the graphs and shapes of the basic polynomials for cubics, which is this first one here, and for quartics, x to the power 4. You should be able to know the shape of a cubic with three distinct factors. Forgot what that means later on. Determine the intercepts of a cubic graph, use the shape and intercepts to sketch a cubic graph, and then determine the equation of a cubic graph when using the intercepts. So a lot of work with cubics here, a lot of work translating what we're doing with equations, translating that into graphs. Right, so the key things to remember, our y-intercept is found when x equals 0, and our x-intercepts are found when y equals 0. Now once we have those values and substitute them in, we may need to do some solving. So solving cubics will be an important skill to remember as well. Alright, so when sketching polynomials, it's important to know the shape of a couple of our key shapes. We've done lines, we've done parabolas. This one here on the left, that's the equation of our cubic. So notice it has a bit of that parabola sort of shape, but instead of going back up on our negative side, it actually goes downwards. So we've got this, looks a bit like a parabola, but instead of that left-hand side going upwards, it's now going downwards. This point here, that's at the origin, 0, 0. It's got a gradient of 0, so it flattens off. And we call that point there, that's an inflection point. Smack bang in the middle of our cubic there. Now on the right here we've got our quartic, so that's x to the power 4. Notice in the red it's got a very similar shape to our parabola, the x squared value, except that our quartic is a lot narrower. So it's been compressed a bit this way, and also it's a lot lower when our x values are between -1 and 1. That red line is lower. It's like it's sort of been compressed a bit. So it's got a similar shape to our parabola, but it's a bit narrower on the top and a bit flatter at the bottom. Just like our parabola, x squared, it also has a turning point at 0, 0. All right, with our cubics, they'll have different directions based on the coefficient of the leading term, or the x cubed term. So here we've got a positive cubic, and notice that generally speaking, it's going upwards. So up at the top here, it's going upwards, and the bottom it's going downwards, just like our line. Our line's going upwards if it had a positive leading coefficient, or if its gradient was positive. This cubic, where x cubed is positive, means it's going upwards. It starts in bottom left, like our line, and goes up, down, up, and rises like our line. For our negative cubic, it follows that same downward trend. So there's a bit in the middle where it goes up and then back down, but generally speaking, just like our line, if our leading coefficient is negative, right, so that'll be negative x cubed, our cubic is going downwards. And that's a big giveaway for the shape that we can expect to see when we sketch our cubics. All right, so we want to sketch the graphs of the following polynomials by finding the x and y intercepts. So for this one, our y-intercept will be when x equals 0. So substituting in x equals 0, we'll have 3 from that first set of bracketed terms, then -1, then -2. All times together, that gives us 6. So our y-intercept is 0, 6. Now for our x-intercepts, that means y equals 0. So 0 equals x plus 3, x minus 1, and x minus 2. And this is just a null factor law problem. So by null factor law, each of these factors must equal 0. So we can say that x could equal -3 from this first term. X minus 1 could equal 0, so x could be 1. Or x minus 2 could equal 0, so it could be +2. So plotting all those points on our lines then, so we've got an x-intercept here at -3, which is right here. We've got an x-intercept at 1 and at 2, and a y-intercept at 0, 6 up here. Now these intercepts I could probably write properly. -3, 0, 1, 0, and 2, 0. And those are all plotted there. And using those dots there, we can then draw our cubic. So we've got, our cubic should look something like this. Just doing our little dot to dot there, drawing our line between, our cubic between those lines. That's roughly what it should look like. Once again, full marks for one like that one if the shape looks right and if your intercepts are right. Alright, this next one, we've got our points again. So for our y-intercept, x equals 0. So we've got y equals 0 times 4 times -2, which just equals 0. So our y-intercept is 0, 0. That's also going to be an x-intercept because it's x is 0 and y is 0. So that should also be one of our x-intercepts. For our x-intercept, y equals 0, so 0 equals -x, x plus 4, x minus 2. Once again, using our null factor law, each of those factors could be equal to 0. So x could equal, from that term there, 0, from this term here, -4, from this term here, +2. So our x-intercepts are 0, 0, -4, 0, and 2, 0. Plotting those points, we've got -4, 0, +2. Now the problem is we don't know which way our cubic's going to go. Is it going to go upwards from bottom left to top right, or is it going to go downwards from top left to bottom right? And this is where our leading coefficient matters. We've got a -x out the front, so when we expand this, it's going to be -x cubed. That means our cubic is going to be going downwards. So here, there's our cubic, and it's going to be going downwards something like that. Obviously a bit neater, but that's the rough shape of our cubic in that situation. Alright, this last one, we need to determine the equation of our cubic from the following graph. Now what we're going to do is use the same equation as before, just with our a value, our dilation or our coefficient out the front. X minus, I'll just use some letters here, b, x minus c, x minus d. And in this situation here, b, c, and d, those should all be our x-intercepts, just like they were in our previous examples. So here we've got an x-intercept at -1, at 3, and 4. So therefore our graph will be x minus -1 or +1, x minus 3, x minus 4 for each of those intercepts. Now we just need our a value. We can just substitute in a value to work out what that a value is. Looking here for our y-intercept, that's at 0, 12. So we can sub in 0, 12, and 12 is going to equal a times 1 in this first term. In the second term, that'll be times -3 times 0 minus -4. So 12 equals 12a, so a must be 1. So therefore our equation must be, we don't need to write the invisible 1 there, but that's x plus 1, x minus 3, x minus 4 is the equation for this particular cubic. Alright, so after watching this video, you should be able to know the shapes of the graphs of the basic polynomials x cubed and x to the 4, our cubic and quartic. Know the shape of our cubic polynomial with 3 distinct factors. Those are the examples we were looking at, and knowing the shape of going upwards or downwards depending on whether it was a positive cubic or a negative cubic. Determine the intercepts of a cubic graph. We did that using null factor law, using the shape and intercepts to sketch our cubic graph. That's what those first two examples were. And determine the equation of a cubic when intercepts are known. That was what we did in that third example at the end.